Asif, okay. So we were discussing the case 4. We discussed the different types. I told you this particular thing. Note करके लिखवाया भी था always. कि wherever there is contact between body, there will be a normal reaction. Always remember, normal reaction will be perpendicular to the surface on which the object has been kept or placed, whatever. है ना? So we have seen these type of surfaces. We have seen a normal ground level like this, completely horizontal. So can you see the normal reaction acting on the block was perpendicular to this surface? Yes or no? Similarly, if I have the surface like this, I place it on an inclined plane, the normal reaction will be perpendicular to the surface of incline. Yes? And the last case was when not the last case, when the surface was like this, vertical, the surface was vertical, so can you see the normal reaction was horizontal? Always remember, the normal reaction will always be perpendicular to the surface on which the object has been kept. So we already did till here. Now let's discuss the case 4. What is case 4? Suppose if I have a curved surface like this, and let's say an object is placed over here, and let's say over here. Yes. Can anyone tell me how will you use the direction of normal reaction in this case? Don't draw other forces. I just want normal reaction. Okay. Please remember, in case of curved surfaces, how will you draw the surface? In case of curved surface, draw a tangent to the surface. Everyone knows how to draw a tangent, right? Where the object is placed. And then after this, what to do? Draw the normal reaction perpendicular to this one. Draw the normal reaction perpendicular to the tangent drawn. Okay. So basically, whenever you have curved surfaces, how will you deal with it? You'll draw a normal, this thing. Acha, in every case, mg was acting downwards towards the center of Earth, right? Mg was acting towards the surface of Earth. Can you see mg is acting towards the surface of Earth? Yes or no, guys? Mg is always acting vertical down because the objects are very small, and this is your normal ground surface and all. Okay, but it's not horizontal; it's a little bit curved. So how will you draw the tangent over here? I'll draw a tangent like this. Will I draw a tangent like this to surface? Can I draw a tangent like this? Can I draw a tangent like this? Yes or no? Guys, is this the tangent in every case? Yes or no, guys? And then after this, we will draw the normal reaction. So the normal reaction is like, can you see? Perpendicular.
So could you explain me the case 3 in the class later, like after the class?
Ha, okay. So this is the direction of normal reaction in every case. Please remember, the normal reaction is perpendicular to this tangent in the case of curved surface. Is this clear, case 4? Guys, is case 4 clear?
Yes,
Now let's see what is the case in the case of circular surfaces. Circular surface is also a curved surface only. But let's see. Suppose, guys, I have a
एक सेकंड में डायग्राम ड्रॉ करा था
draw it first.
या डन सर डन
So this is suppose I'll use the out of. Suppose, guys, this is your circle and the object is placed over here. This is the center of the circle. Can anyone tell me how will you draw the normal reaction in this case? I'm not drawing the
so
diagram.
you will draw it to the center the mg nature
I'm
will
not
touch the
drawing
center.
mg first. I'm just wanting normal reaction. Everyone knows how to draw mg now.
So Will go through C.
Exactly. So in case of circular surfaces, case 4, always remember when you draw the tangent and the normal reaction will look something like. So can you see this passes through the circle? The direction of normal reaction is radially outwards when the object is placed outside the circle. Is this clear, guys? Okay. And what about the next case? Although it is the same case only, but if the object is placed inside, suppose. What if the object is inside? If the object is like over here, then what to do now? I'll draw the tangent again.
So it will again go C.
I'll draw the tangent again, and then I'll draw the normal. Can you see? Again perpendicular, again perpendicular. But in this case, the normal reaction will pass. It's radially inwards, not radially outwards.
So object under.
Object under है.
So it's a whole object.
Is this clear, guys? Is this clear, case 4?
Yes.
Circular surfaces.
So radial also they are fine. मैं लाइट ऑन करके आ सकता हूँ?
What? हाँ करो करो.
Yeah.
Now suppose एक question देता हूँ.
Yes, sir.
So guys, can you see in the figure there is a sphere, and there is a this is a stair, suppose. है ना? So there is this sphere, है ना? So I want you to draw the normal reaction. Normal reaction. How many normal reactions will be there?
So 1,
2. Ask me why.
2, 2. ये this stair के edge पे
Exactly. There are
और ये stair के
2 contact points. So can you see 2 contact points? One is over here. One contact point is over here, and another contact point is over here. Yes or no? Yes or no, guys?
Yes, sir.
So basically, if I talk about what is the normal reaction acting on this pair, then what will it be? I'll draw a tangent. I'll draw a tangent. So can you see the tangent in both the cases? Yes or no? I told you na कि this pair will. Can you see the object is stairs and this is basically the spherical surface. So what is the direction of normal reaction of on stairs? Stairs due to stair, and this will be the direction of normal reaction due on stair due to stair. Yes or no? I'm not naming this as NSTG sub. I'm just naming this as N1 and this as N1. Yes or no? Can you see this
Yes,
point
sir.
over here again? Achha, by the way, this will pass through the center. What about the next one? The next one will also pass through the center, but the normal reaction will be something else. Okay, it will be N2, it will be N1, it will be something else. So the contact points are different, so hence we will draw different normal reaction. Is this clear? Yeah, that's the answer to your question. So I think,
मैं ये ड्रॉ नहीं कर रहा,
huh?
मैं क्वेश्चन ड्रॉ नहीं कर रहा.
Draw कर चुपचाप.
Answer.
So this is how you draw the normal reaction. Any doubt in normal reactions?
No, sir.
Let's talk about a third force, and then we'll start with the questions and all. We'll see how we do the questions, and then later on we'll keep on increasing, the number of forces. We'll keep on what panel? So whenever you're done, guys, just tell me. The next force is tension in a string. Hello, Tanya, what is happening?
Yeah, my Wi-Fi connection just got lost.
Okay. So
Yes.
third force, guys. The first force was weight. The second was normal reaction. Now the third force is tension in a string. These are the most common mechanical forces. ये हर बार आएगा. In the grade 11, grade 12, so these will be there. Okay. So always remember, suppose I have a support through which I have a string, and through that string I have connected a block of mass m. Okay. So what will happen on this particular thing? Whenever, can you see this? When this mass will be hanging from the string will be tight. Yes or no? It will be in a stretched condition. Yes or no? Hello.
Yes.
So always remember,
Yes, sir.
whenever there is a string which gets so whenever there is a string which gets taut due to action of some force on the system or any part of the system, then a force called as tension develops in the string. Okay. So basically there is a tension in this particular string. If the string snacks, you understand what do you mean by slacks, right? If the string becomes, hello, कभी रस्सी ढीली पड़ जाती है तो if the string slacks, okay,
What's that?
हाँ, then the tension in it becomes approximately equal to 0. Okay, is this clear, guys?
Yes, sir.
एक बहुत ही कॉमन सेंस वाली चीज है, बट आई थिंक आई शुड राइट इट ओवर हियर. Always remember, strings can only pull a body.
What do you
They
mean by
can,
when the string which gets taut due to the action of
due to the action of some force on the system or any part of the system, then a
Basically,
force.
some body is hanging.
हाँ अभी एग्जाम्पल के रूप में I have given this. There will be complex systems as well. Okay, the strings can only.
So what is C by G?
What is
C by G?
C by A? C by G is called as. Called as.
Okay, okay.
कितना टाइम हो गया पढ़ते पढ़ते लड़की? Then a force called as tension develops in the string. If the string slacks, tension in it becomes zero. Strings can only pull a body; they can never push. Push. ये हमेशा याद रखना. Although it's a very common sense, but remember this. Okay?
So T means
T कभी string ढीली पड़ गई. If the string slacks, then the tension in that string becomes zero. Tension. Shall I write it in words?
if tension is zero, the string will break.
String breaks नहीं, string slacks भी होगी, string break कर दी तब तो होगा ही होगा. So I'm talking about when the string
Almost
slacks.
on the almost on the,
What?
basically when the string gets weak, it becomes zero.
Weak नहीं थे मेरे भाई. जब string when the string will break, the tension will become zero और string will slack. Slack समझ में आ रहा है? कभी तुमने एक रस्सी ली उसको दोनों तरफ से खींच रहा है, तो उसमें टेंशन है. But when
थोड़ी
you
लंबी हो जाती है.
हाँ अभी यहाँ पे लंबी करनी नहीं है उसमें. We have light inextensible string है ना. I'll make you right. And उसको तो ऐसा पास में लेके आएगा अपने हाथ को तो रस्सी ढीली पड़ जाएगी. And the रस्सी will become ढीली, but the tension will become zero.
I got it.
Okay.
So if using strings can never pull a body,
Yes.
तो reaction force क्या होगा?
Reaction force contact पे आएगा. Okay. Here the string is directly connected to the block. Okay. So here we just draw tension. No normal reaction. No nothing. Okay. Normal reaction when surface से contact में होता है. Is this clear, guys? कितना समझ में आया? Hello.
हाँ सर आया.
Now let's talk about what an ideal string is. An ideal string has
String is
following
slacks.
assumptions. An ideal string has following assumptions. First, the string is massless. Or you can say its mass is negligible.
What I do is that I have captured that particular URL and I have observed that there is a treated data.
Okay? So basically, this is the first assumption that the string will not have any mass. So always remember, whenever you will do any problems based on Newton's laws of motion, you will not consider the mass of the string until unless not mentioned in the question. Okay? So shall I write it over here? What do you need to consider out of this? I'll write that as well. Don't consider the mass of string until and unless mentioned. Okay? So is the first assumption clear, guys?
So एक second sir. So this mass. Yes. So mass. अच्छा string is mass. Yeah.
Okay, string is massless, mass is
Yeah.
negligible. Now, second assumption which we take is basically the string is inextensible. Inextensible. That implies its length can't change. So no stretching, no compressing, okay? Are you getting my point? Tanish, now getting?
हाँ so got it.
So its length can't change.
So insensitive क्या?
Inextensible.
Inextensible. Inextensible.
So this is your ideal string. Okay, but we know ideal string they don't exist. Real strings exist. The real string will have certain mass. Real strings are extensible as well. So it will change the system a little bit. But for understanding purposes, initially we will assume that everything is ideal. Okay, is this clear, guys? Is this clear, guys? Hello.
Yes, sir, it's clear, sir.
Chalo. Uh, I'll tell you some rules to draw tension. In an ideal string. Okay. So whenever you have an ideal string, how do you use two different rules? First rule is tension always acts towards the support. So tension always acts towards the support on the object connected to the end of the string. For example, suppose in the previous case when I drew this diagram, can you see there was a rigid support over here? A rigid support, and let's say there is a block and I have connected it with a string. So can you see that string I made it with red just for understanding purposes? Can you see the two objects involved in this place?
The
What are
rigid support
and the
body.
whatever block? Okay. So these are your two objects involved. Can you see these two ends of the string? Can you see the one end is connected to the rigid support and another one is connected to the block, right? Okay. Hello.
Uh,
So basically, what will happen? The block will apply a mg downwards. Yes or no? Due to which the string will become tight. Yes or no? Yes or no,
yeah.
guys? So please remember, for point A, I'll name the ends as A and B at the ends of the string. For A, the support is B. Always remember, A खुद का support तो कर नहीं सकता है. Can A remain stretched by on the by supporting itself on itself? आया ना? String कभी भी support करेगी. So basically B will take the support of A. So basically B पे जो tension लगेगा will always act towards its support. So for B the support is A and for A the support is B. Are you getting my point?
Yes,
So for B the support is. Please remember A is basically nothing but the rigid support over there, and B is nothing but the block. So can you see, for the rigid support the support is block, and for B the block, in spite of naming it as a rigid support, you can just name it as roof or anything else, whatever you want. Till the time you don't get confused, it's fine. This is the terminology which we are using. Okay, support क्या है? तो ये ध्यान रखना. So for always remember, for A B is the support, and for B A is the support. So always remember, tension always acts towards the support. That implies this will be the direction of tension over here, and the second will be this will be the direction of tension over here. Is this clear? Guys, did you understand the question? Did you understand the first rule? Always towards the support. Don't worry, I'll give you questions to draw this tension and all. Ultimately, it will get clear. Whenever you're done writing, send.
We have done it in two parts, and for one we got two. Now, if you want more, you can the extra file, you will have more users. Only one account has, yeah, yes. Yeah, yeah.
Guys, whenever you're done.
That is why we are pushing.
The second rule. The second rule is in an ideal string. If the string is taut, then the tension at every point on the string is constant. So if the string is taut, so please remember tension at every point on the string in between A and B. Can you see this string in between A and B? That includes A and B as well. We are not concerned of the points which are there in between A and B. We are just interested in at the ends A and B. So can you see over here the tension at A and the tension at B? I have taken them as equal. Can you see this thing, guys? The tension at A and tension at B are both equal to T. Yes or no? Otherwise, if they would have been different, I would have taken them T1 and T2, right?
I think it is,
Yes or no, guys? अरे हाँ है ना?
I don't know.
Hello?
Downloaded it on computer.
Sir,
Now that
क्या आप मेरे को सुन पा रहे हैं?
what?
Guys, can you hear me?
Yes, sir,
So
we can hear
always
you.
remember, in an ideal string, the tension at every point in the string is constant. If the string changes, string is changed,
for the last month, we downloaded and we are getting
the tension
network
in that different string
because I think uploaded downloaded the idea after we download the site, we need to update all those records in the backend. That's it. Okay. So what happened is
for example, suppose I'm
so
giving you a question.
There is a huh?
Guys, can you see I have given you two blocks of mass m1 and m2? The question is, draw the forces on m1 and m2. So yes, how many forces are acting on
You
this block?
scroll up,
First of all,
so I have to write.
huh?
You scroll up, so I have to write for you.
Yes, guys, please draw the force. कहाँ पे लाए लिखा है?
SCP, the second one. And
We have
I think
Others might be bound to hold this new to another people they have not yet ideally.
Guys, not like there are only these three forces involved. There are many forces which are there which you'll learn about throughout your 11th and 12th. So basically, we are just you know studying how to deal with those forces and all. Okay.
Real time data. Okay. But then
We are just introducing forces one by one. Now I'll give you some questions which are based on these three forces, and whenever a new force will come, we'll introduce it. Okay.
okay. So there is other question. Electric force is actually
So yes, can anyone tell me what are the forces acting on M1? First of all, M1, will it weight act downwards? Hello? Will its weight act downwards? Will this M1 mass multiplied by G act downwards? So can you see this is the weight? Can you see this is the weight of the second object M2G? Yes or no? Yes or no, guys? Guys, now can you see these two are pulleys? They are pulley. You understand what a pulley is, right? Guys, do you understand what a pulley is?
Ah,
So now see how many different points are there. Can you see? This whole string is a single string. From point A to B to C. Just learn it how to draw the same thing exactly like this. E and F. So basically this is your string one. From A, B, C, D. And there is one more string. String 2. Can you see this string 2 from here to here? Can you see this is another string? So this is G and so this is basically your second string GH. Now how many different points are there? Can you draw the tension at every point? Can you see at point F, E will be the support. So this will be the tension. At E, F will be the support. And at point D, C will be the support. At point C, this will be the support. So can you see this is tension T, tension T. Guys, are you able to see these points? Hello? Guys, are you able to draw all this? Can you see now?
yeah.
For
Yes,
point
sir.
F, E is the support, E के लिए F support, D के लिए T support, D के लिए C support and C के लिए D support. Similarly, B के लिए A support and C के लिए D support. Yes or no? So can you see over here? I have named this tension as P T T T T T T T T. What will be the tension in the second thing? What will be the tension in this? Will it be same to this? Same as this? Hello guys, will it be same as T or it will be something else? Yes, can you tell me please? Will it be same as T or something else? It will be?
Same.
It's a different string. If the string is changed, the tension in that other string is different from the first. Anna? So the tension over here will be different. So let's name it as different. क्या नाम दो इसको? Let's name this as T2. So can you see T2 T2 acting at point G and H? Yes or no? Whereas on in the first string it's T1, 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 T1. So what is the tension in this string? It's T1. And what is the tension in this string? Are you getting my point, guys? Now is it clear how to draw the forces? Hello?
Oh, yeah.
Yes, sir.
एक और question दो. Shall I give you one more question?
Yeah. Yes, sir.
There is an inclined plane on which there is a pulley connected. From this pulley, there is another pulley. This is connected to a support. This is connected to a block, and this is connected to another block. The inclined plane is fixed over the surface. It cannot move. Only these blocks can move. Okay, okay guys. Only the blocks can move. And now, can you tell me what all forces will be acting on M1 and M2? Can anyone tell me what all forces
But
start
M1
from?
का जो string है उस पे one force is acting.
हाँ वो सब बाद में पहले start from where will you start from always?
Contacts.
Huh?
Point of contact.
नहीं, you will always start from drawing this thing. Wait, the first thing first. M2G, M1G. Okay, this is the first force. Now what was the second force? The normal reaction, right? Hello.
Yes, sir.
So what was the normal reaction? The normal reaction was, can you see the contact? Is M2 in contact with any surface? Or M2 is just hanging in air with the help of a string? Hello?
Yes, sir.
Is M1, M2, this block, in contact with any surface? Is this in contact with any surface? M2? Or is it just hanging in air with the help of the string? Can you imagine the whole thing in place in front of you? Hello?
Yes, sir.
अरे यस सर नहीं मेरे को बताओ ना मैं सवाल पूछ रहा हूँ उसका जवाब दो ना एवरीवन अनम्यूटेड प्लीज अनम्यूटेड अनम्यूट करो कोई जवाब भी नहीं देता यार पूछता हूँ तो मैं
Can you repeat the question?
हाँ I'll repeat the question but please unmute Cyril unmute Aman unmute please Aman can you please unmute yes Cyril please unmute your phone साउथ सर एक बार सिविल को मैसेज करेंगे कभी नहीं है तो मैं उसको क्लास से निकाल रहा हूँ बात guys I want responses from you people don't respond है ना मेरे को बहुत गुस्सा आता है उस टाइम पे प्लीज आई एम आस्किंग यू वन मोर टाइम फिर से सुनो क्वेश्चन ध्यान से सुनना is this
There's a lot
block
of background noise, sir. I can barely hear your voice.
एक सेकंड वो उसकी भी मीटिंग चल रही है ना इन माय रूम में इज हैविंग सम मीटिंग्स एंड ऑल्सो इवन मी स्टॉपिंग
Could you like get the mic closer to your
हाँ now
Could you get
can
the
you hear
mic?
me can you hear me now
There's a noise.
hello
It's okay.
so can you see this M2 I'm asking whether this M2 is in contact with any surface or not
No,
is
sir.
this M2 hanging in air with the help of this string or is it in contact with any surface this was my question
It's just hanging in air.
तो फिर यही चीज तो मैं पूछ रहा था कब से जवाब क्यों नहीं दे रहे थे so here there is no normal reaction acting on M2 because it is not in contact with any surface only M1 is in contact with this surface right so will there be a normal reaction acting on M1
Normal reaction is of the force string, no?
normal reaction on the string
Of the string. The M2.
फाइन स्प्रिंग कब से नॉर्मल रिएक्शन लगाने लग गई स्प्रिंग तो टेंशन लगाती है ना स्प्रिंग
And the tension will be equal to M2G.
अभी ये मैंने बोला हूँ कि कोई इक्वल है कोई कुछ है. अभी आई एम जस्ट आस्किंग व्हाट इज द फोर्स, व्हाट इज द डायरेक्शन, what I have been teaching you from the first class, how to draw the direction for normal reaction, how to draw the direction for tension. Is this, did I tell anything about कि whether normal reaction is equal to this or that is equal to that? ऐसा कुछ बोला है कि नहीं? I'm just telling you to draw the force. So anyways, M1 is perpendicular to this surface. Can you see the fixed inclined plane? So basically, if I draw this, then this will be the direction of normal reaction. This will be the normal reaction, which is always perpendicular to the surface. Can you see on the surface it is perpendicular? Any doubt till here? Now the last force is basically the tension force. So can you see this string from these points? All these points are there. All these parts are a part of the string one, right? So there will be a tension T1 over here, tension T1 over here, tension T1 over here, tension T1 over here, here, here. So can you see I have drawn the tensions at every point? Can you see support, concept of support? For this point, this is the support. For this point, this is where the tension is acting like this. Now, what about these 2 points? Can you see these 2 points? This is another string. This is another string which is connected to the center of this string. When you draw a tension like this will be your T2 and similarly this will be your. So these are the forces which are acting on the block. How many forces are acting on it?
Sir, what is the support for the second pulley?
What is the support for the second pulley? Like you always talk about the support for the points. Support is not a technical term. मतलब you basically you can just for the pulley you can say this point and this point is the support. These two
Yes,
points are making the pulley float in air. Yes or no?
yes, yes, sir.
Whereas strings के लिए this point and this point is this point and this point is है ना? So you need to draw these diagrams on your own. Once you start drawing these diagrams of which is indicating all these forces and all, we draw something called as free body diagram. So this is what we have drawn. ठीक है? So is this clear? बनाओ बनाओ धीरे धीरे सीखो,
Yes,
कोई
sir.
दिक्कत नहीं. इट्स नॉट नेसेसरी कि एक ही वन शॉट में तुमको आ जाएगा सब कुछ. धीरे धीरे बनाओ. ड्रॉ इट, ड्रॉ इट, लर्न इट, लिटिल बाय लिटिल. Draw the previous diagram as well as this diagram. बोले करो यार. At least if you are keeping your mic mute for a long time, at least at that time where I'm speaking, no, तब उस time पे reply कर देगा. South sir? Hello South sir?
Should we draw this?
Hmm?
Should we draw this?
Cyril, where were you?
So sorry, sir, my mic wasn't getting unmuted.
Chalo, everyone done? Have you drawn these two questions now?
Yes.
थोड़ा सा बना के we'll learn about these free body diagrams. Okay, so give the heading free body diagram. We'll include some more forces later on in the chapter, but let's see once we have drawn all the forces, how do you draw it, and how do you deal with it? So there is something called as free body diagram. This is very important for your whole 11th grade. Please pay attention over here. Okay. So what is a free body diagram? It is basically a diagram showing all the forces acting on. So basically, once you know how to draw all those forces, you'll just draw a free body diagram of the situation, and hence you'll try to solve it further on. So it is a diagram showing all the forces acting on a body. Please remember, it is only on the body. We draw only those forces which are acting on that body, considering the body as a point mass after isolating it from the system. Let's start understanding what exactly is a free body. Do you remember the first case where I have drawn this room for ceiling, and there was a object which was hanging with the help of a string? Yes or no? So you drew the forces acting on this object. What was the direction of forces on this object? On this object. Or first of all, draw the all the forces which are there. Can you see? Tension over here. There is tension over here. There is M1G over here. Yes or no? Mg over here. Yes or no, guys? Now, how many blocks can you see in our system? How many blocks can you see in this case? Guys, hello?
The what?
How many blocks can you see in this diagram?
One.
Only one. So there is only one diagram. So basically, isolation. This is something called as isolation. I'll tell you what exactly isolation means. Now, don't pay attention on anything else. Just pay attention on this. So just how do I say it? Don't think don't even pay attention over here. Don't pay attention over here. Just only pay your attention on this part of the object. Only on this part. Okay. Once you draw that, what do you do? How will you draw this free body diagram of M? Is consider this M as a point mass. So can you see? I have considered this M as a point mass. This is my M. Now can you see Mg was acting in the downward direction? So Mg was acting in the downward direction. Yes or no? And the tension on it was acting in the upward direction. So can you see there were only two forces acting on this particular thing? I isolated the whole thing and drew the free body diagram. So this is basically the free body diagram of mass M. Is this clear? Is this clear, guys?
Yes.
Yes, sir.
So this is something called as free body diagram. We'll take one more example. The example which we just discussed over here. Control C. So now, guys, can you see how many objects are there in this system? How many objects are there in this system? The second example.
2.
So basically, how many free body diagrams can I draw? I can draw two different diagrams, right? Can you please, will you be able to draw the free body diagram of M1 mass And will you be able to draw the free body diagram of M2 mass? So what to do in the first case? You'll assume both of them as point masses. Yes or no? So you'll assume both of them as what? Point masses. Yes or no? Once you assume them as point masses, what will you do? You'll say, the forces. Can you see? Let's talk about M1. Isolation. Guys, you remember isolation? So I'll just isolate this. And I'll just isolate this. Can you see over here? I don't care about what else is there in the system. I just want, since I was drawing the free body diagram of M1 and M2, so I just isolated M1 and M2. So my all attention should be on M1 and M2. Now, what forces are acting on M1 and what forces are acting on M2? There is one force acting on M1 in the downward direction. So M1G is acting in the downward direction, and M2G also is acting in the downward direction. What else? Can you see a tension T2 is acting on M1? Can you see a tension T2 is acting in M1 according to the question? Yes or no? Okay. So tension T2 was acting on M1. And what is the tension acting on M2? It is basically. Can you see? This T1 is drawn over here. This M2G is drawn over here. Similarly, this M1G is drawn over here, and this T2 is drawn over here. So can you see, guys? I have drawn all the forces which were acting on this particular blocks. Any doubt? Acha, can you draw the free body diagram of this pulley? Can you draw the free body diagram of this pulley? What will you do again? Isolate. So when you isolate this thing, so you only see this much. If I draw the free body diagram of pulley, you'll assume the pulley as point object. And can you see one T1 is acting in from right and one T1 is acting from left? So can you see T1 is acting from right and one more T1 is acting from left? Yes or no? So what is the total T1 over here? And can you see one T2? Can you see this blue one? This blue T2. It is acting in the downward direction. So T1 upper and T2 is in the downward direction. Now is it clear, guys, how to draw the free body diagram?
That's easy, yeah.
Hi, it is easy. It is easy. But you need to think of each and every force. Start from weight. Then, if there is contact, go to normal reaction. If there are strings involved, then go to tension. Once you are done with drawing all the forces, this becomes your free body diagram. Can you draw the FBD in this case? Achha, first of all, draw the FBD in the previous cases. Once you're done with drawing the FBD, then we'll see how to deal with the questions. Chalo, note it down, please. Give me 2 minutes. Guys, whenever you're done, just tell me. You don't need, guys, you don't need to draw this again. You need to just draw the free body diagram where you have drawn the initial diagrams. Okay. Is this clear, guys? Any doubt till here? I think free body diagram सबसे easy पड़ेगा. Once you know how to draw free body diagram, then उसके बाद से problem करना becomes easier. Because most of the students, they don't even know what free body diagram is. Even in school, the teacher will not tell you it is called as free body, मतलब they might use the term free body diagram, but ऐसा है कि उसको detail में कोई नहीं पढ़ाता. They'll just give you set of problems and they'll just tell you to use the free body diagram to solve it. That's it. They'll not do anything else. Is this clear, guys? Any doubt till here? Hello? Guys, any doubt till here?
So,
Are you done noting it down? ठीक है. Chalo, let's continue. Let me give you some more questions on free body diagram so that at least you'll be able to make this perfect. Once you'll be able to make this perfect, then आगे का problem is easy to do. Although it will also take certain demand, but yes, can you draw the free body diagram for M1 and M2 in this case? Where is the pen? So if I draw the free body diagram of M2, this one. First thing is isolate. Don't worry, I'll write the steps so that you will understand how to solve any problem on mechanics. Any problem on mechanics can be used, solved with the help of that. So free body diagram of M2. Can you see M2G acting in the downward direction? Can you see this force acting in the downward direction? Can you see a tension T2 acting in the upward direction? The T2 acting in the upward direction. Can you draw the this thing free body diagram for this pulley? So FBD of that pulley is basically pulley. इसका नाम दे दूँ मैं? T1. So on this pulley there is two T1 which is acting in the upward direction. Can you see I have clubbed this T1 and T1 together and I just wrote 2 T1, and there is this T2 acting in the downward direction. This is the free body diagram of this pulley P1. Now let's name this as pulley P2. है ना? So what is the free body diagram of this pulley P2? Can you see this was the pulley, one tension T1 was acting in the downward direction and one T2 T1 was acting in this direction. Also there will be a reaction force which will be in this direction, but this comes under a little bit typically advanced question. We'll learn about this reaction force later on. Okay. Now what about the free body diagram of M1? Can you see M1G acting downwards?
yeah, yes, sir.
This one. This tension T is acting in that direction. So can you see
T1
T1 acting in that direction? And perpendicular to this T1 there is the normal reaction. Is this clear? So this is the free body diagram of your M1 block. Kindly note it down. Shall we write the steps for FBD? Guys, shall we write the steps for FBD? How to solve any problem in mechanics? Hello.
sir.
बोलो.
Yes, sir.
Done?
Yep.
Everyone done drawing the free body diagram? Cyril in doubt?
Yes.
Hello, Cyril?
Sir, no doubt.
Okay. So write down the steps for free body diagram. We'll have some more questions directly on, so don't worry. It's not like I'm just giving lesser practice on free body diagram. The questions which I'll give actually will, you have to make the free body diagram in order to understand the question. So we'll see it, okay? Steps involved in free body diagram. First step is isolate the object. So you understand what isolation means, right? Isolate the object from the system. By isolation, what do you mean? You're not breaking off ties between the object, you are just concentrating only on that object. Okay? So when we are isolating, that implies we have to focus only on that object, or basically the forces which are acting on that object. Is this fine? Is the first step clear? First step is easy, right? You don't need to
Yeah.
cut off the ties between. Can you see isolation? It's not like when I am talking about isolation, so I cut this string and took the object somewhere else. No, isolation means ki when I'll be seeing only M2, nothing else. If this I'm isolating M2, that implies I will not be seeing what forces are acting on M1 and all. I'll be just seeing this P1 and I'll be just seeing this M2. Any doubt in this? So this first step is called as isolation. Now the second step is to draw all the forces acting on the object. You don't draw the forces which are applied by the object. We always talk about those forces which are applied on the object. Is this clear? Once you draw this thing, these two steps will consider your ability. Now, how will you solve the problem? The third steps onwards is basically for problem solving. Okay, guys? Guys,
Yes, sir.
steps 3 to whatever it will go is based on problem solving. First step is choose a frame of reference. Okay?
Yes, sir.
Choose a frame of reference. What is a frame of reference? Basically, it's just a set of. I'll write that as well. It's a set of two mutually perpendicular axes. So basically, drawn on the object. इसके पीछे भी कुछ सब steps हैं. If the object is at rest, then there is method to choose the frame. Please remember, the object is at rest, then choose a frame of reference in such a way that maximum number of maximum number of forces lie in the frame. Don't worry. I'll give you step by step example as well, so that you should know when to apply which step. If object is accelerating, so please remember rest or uniform motion is one and the same thing, na? For rest and uniform motion, you apply the same thing. If the object is accelerating, okay, hello,
Yes, sir.
then choose a frame of reference in such a way one of the axis of the frame lies in the direction of axis. Now let's see. What do you mean by step 3? Please remember guys, ऐसा नहीं है कि I'll give you this whole thing first and then I'll start explaining the steps. No, step by step अपन will explain each and everything. Suppose there is a block which is kept on a smooth horizontal floor and I'm applying an external force F on this object. Okay, hello guys, hello. So can you tell me if this is a smooth horizontal floor? Guys, tell me this particular thing. If this is a smooth horizontal floor, then will this object be at rest or will this object be in motion? Guys, please tell me. If this is a smooth horizontal floor on which there is a block placed and I am applying a force at certain angle, theta. So will this object be at rest or will it start moving? Hello.
Yes, sir. Hello. Hello.
हाँ सुन रहा हूँ मैं. So this
Hello.
object will keep on moving. Let's say it goes with an acceleration A. Now I had, can you tell me if you draw the free body diagram of this object, so there will be an mg acting in the downward direction, there will be a normal reaction acting in the upward direction, and there is one more F which is acting at an angle theta. Okay, so I could have chosen, I may choose, one frame which is like this. I may choose one frame which is like this. It's up to me. No, I need to choose two perpendicular axes, right? Yes or no? So I will not be choosing this frame because I'll be choosing this frame over here. Why do I need to choose this frame? It's basically, can you see, when I choose this frame, one of the axis lies in the direction of acceleration. So that is why we'll be choosing this. Is it clear? Check. Similarly, I'll give you one more example again. If it's like this, let's say, suppose this is an inclined plane uh, of angle theta, and let's say there is this uh, object of mass. Can anyone draw the this forces? Please draw the forces. Mg acting downwards, normal reaction acting perpendicular to the plane, and that's it. If this is a smooth horizontal ground, then no friction as well. Yes or no? So basically, this object will slide down this inclined plane? Yes or no? So this object will accelerate like this. Now I have again option of choosing two different frame of reference. I can choose a frame of reference in such a way that this mg comes in this direction and this normal reaction goes like this. I can choose a frame of reference like this, or I can choose a frame reference like this. It's up to me, no? In which direction to be chosen as. So, can you tell me, guys, which will be the frame chosen in the case? Which should be the frame chosen? Is this should be the chosen frame or this should be the chosen frame?
So, and then the first, second,
This is the
first
first one. This is the second one.
first one.
First one.
First
We'll
one's
choose
correct.
the first one, right?
Ah,
Wrong. We'll choose the second one. Why we'll choose the second one? Because the object will be sliding down, accelerate. So when it will be accelerating down the plane, we need to choose this frame of reference, because can you see this axis of the frame? This is lying in the direction of acceleration. Is this clear? Is this clear, bhai? So we will be choosing this as the frame of reference. Is this step clear? Always, the normal ones are easy. Normal one, you can just choose any frame which will have like, most of the forces involved inside it. So anyways, is this clear, guys? Third, is three clear? Second, we'll learn about the other cases in the next class. And I can give you step number 2. नहीं जाने दो. Shall I give step number 4 or shall I just leave for today? Huh? Hello?
yes, sir.
Tell me.
You can give step 4 too.
So this is your step 4. Step 4 is basically to resolve all the forces which are out of the frame. Those forces which are lying inside the frame, it's not a problem. But those forces which are lying outside the frame, it's a problem. Now, this is a very nice step. So, एक बार फिर से we'll do all the questions again. So, can you see over here? This is a block of mass M which is placed over the ground. How many forces are acting on it? How many forces are acting on it? Mg,
Sir,
Mg acting down, and since it is placed on ground,
no,
two forces are acting on this. Yes or no?
the normal and mg.
हाँ, but normal and mg. So there are these two forces. This object is at rest. Yes or no? If I am saying this block is placed over the ground, so if it is at rest, it will remain at rest. No, there is no driving force. Is it digging down inside the earth and going down? Is it flying up? If it can't fly up, if it can't go down, then that implies it is at rest, right? So what is the frame which you will choose? You choose a frame like this. Can you see the green one? Why have I chosen, the green one? Can you see there were two forces are acting, and I chose a frame in such a way that, can you see, the object was at rest, so both the forces, they came inside the frame, right? Yes or no? Yes or no?
Yes, sir.
And suppose एक और example. If I give you one more example, suppose there is friction also involved, है ना? So there is this block. I'll draw it again. So suppose there is this block which is placed on a ground, but it is rough. So whenever it is rough horizontal plane, then that implies friction will come into play. Okay. Whenever it was smooth, no friction was there. Now tell me this: suppose if I am applying a force F, at an angle theta with the horizontal. So can anyone draw what all forces are acting on this thing? This force is given in the question itself. And okay, we are applying this force on this object, but still this object is not moving, still this object is at rest. What all forces are acting? There will be mg in the downward direction, there will be normal reaction in the upward direction, there will be friction in the backward direction. This friction will try to prevent it moving towards the right because of the application of this force. Although we have not studied it, but still, I'm just taking for an instant. Okay. So if I draw the free body diagram of this mass m, then will it look like something like this? Mg in the downward direction, F in this direction at an angle theta, right? Normal reaction in the upward direction, and F in the backward direction. It's something like this, okay? And this object is at rest. So now can you see the guys third step A? How will you choose the frame of reference? You choose the frame of reference. Now you have two different choices, है ना? Guys, can you see you have two different choices? I can choose a frame of reference like this, and I can choose a frame of reference like this. When I choose a frame of reference like this, normal reaction will lie inside the frame, mg will lie inside the frame, friction will lie inside the frame, but capital F will lie outside. When I choose the second frame, capital F will lie inside, N will lie outside. Can you see? N is not lying on the axis. N is not lying on the axis. That's why we can say N is lying outside. Mg is outside, and F is also outside. So can you see over here, guys? Tell me which frame would you prefer to choose, the first or the second? Which frame will you choose, the first or the second? Can you see in this, the object was at rest and there were three forces which were in the frame, only one force out of the frame. But the second frame you had like only one force in the frame and three forces out of the frame. So which will you choose, first or second? Yeah, you will be choosing the first frame. Okay. Why? Because the maximum number of forces are inside the frame. So once you have chosen the frame, step 4 is to resolve that force which is out of the frame. So can you see over here, N was inside, Mg was inside, F was inside, only capital F was outside. So when capital F was outside, what will you do? You will resolve this F into two components. So can you see F will disappear from here, and I'll resolve this F into two components. What will be the component which will come over here? It will be the cos component. And what will be the component which will come over here? It will be the sine component. Always remember, the component of force with the angle is cos. Component of any vector which makes the angle theta with the resultant with the vector is the cos component. Cosine component. Always remember this. The one which is having theta with it is always the cos. The one which is having sine, the one which is left out is basically the sine. And the other one is sine. So basically what will happen to this thing? This thing will be converted to n upwards, mg downwards, f cos theta in this direction, f sin theta in this direction, and small f in this direction. Small f is the friction. So can you see, guys, after resolving the forces, is every force in the frame now? So till when do you resolve? We resolve till every of the forces in the frame of reference. Is this clear, guys? Is the fourth step clear? Guys, is the fourth step clear? Fourth step is to resolve the frame, all the forces which are out of the frame of reference, and we, by resolving it into two components, we bring them inside the frame. Once we have done that, after this we will study in the next class. So please draw this diagram. Please, we will do lots of question. I'm just explaining the method